The universe is enormous, so enormous that the human mind can barely comprehend its scale. Billions of galaxies, trillions of stars, countless planets, and cosmic phenomena exist within a vast space that humanity has only just begun to explore. But the more scientists look into space, the more mysteries they discover. Astronomers are used to strange things. They study black holes, neutron stars, supernova explosions, and collisions between galaxies. These phenomena can be incredibly powerful and sometimes terrifying, but at least they follow the known laws of physics. However, sometimes telescopes detect something that completely breaks the usual picture of the universe. Sometimes it is a star behaving as if something enormous is being built around it. Sometimes it is a signal arriving from deep space with an almost impossible level of precision. Sometimes it is a gigantic structure so massive that it challenges the fundamental principles of cosmology. And the most astonishing part is that scientists still cannot fully explain what they are observing. Over the past decades, modern telescopes, space observatories, and radio arrays have revealed many such mysteries. Some of them have forced scientists to rethink existing theories about how the universe is structured. Others have inspired hypotheses so unusual that they sound like science fiction. But sometimes, the most unbelievable ideas turn out to be closer to the truth than anyone expected. Today, astronomers are observing objects that may be remnants of ancient cosmic catastrophes, unknown astrophysical phenomena, or, in the most speculative theories, even traces of highly advanced civilizations. Of course, most scientists approach such ideas very carefully. Science demands evidence, not imagination. But when observations refuse to fit into existing models, researchers have no choice but to ask new questions. And sometimes, the answers turn out to be truly shocking.
One of the strangest examples is a mysterious star that made scientists briefly consider the possibility of gigantic artificial structures in space. Astronomers first noticed its unusual behavior while analyzing data from a space telescope that was observing thousands of stars at once. Its mission was simple: to search for planets passing in front of their stars. When a planet crosses in front of a star, the star's brightness slightly decreases. This event is called a transit, and it is how thousands of exoplanets have been discovered. But one star in the constellation Cygnus behaved very differently. Its brightness did not drop by fractions of a percent, as happens when a planet passes by. Sometimes it dimmed by as much as 20%. This was astonishing. No known planet could cause such a massive drop in brightness. Even more puzzling, the dimming happened in completely irregular patterns. It could last for several days, disappear for months, and then suddenly return again. Astronomers checked everything. They suggested that a cloud of comets might be orbiting the star. Then they proposed a massive disk of dust. Later, they considered that it might be the result of a planet being torn apart. But none of these explanations completely matched the observations. Then a phrase appeared in a scientific paper that instantly caught the attention of the entire world. Some researchers cautiously mentioned the possibility of a Dyson sphere. This is a hypothetical megastructure that an advanced civilization might build around a star to capture its energy. If such a structure existed, it could partially block the star's light, exactly what astronomers were observing. Of course, most scientists consider this extremely unlikely. But the mere possibility that the phenomenon might not have a natural explanation created enormous interest. The star eventually became known by its unofficial name, Tabby's star. And although new explanations have been proposed over the years, the mystery surrounding it has never been completely solved. Yet this is only one strange object among many cosmic mysteries. In another region of the universe, scientists discovered something even more puzzling: a gigantic structure made of thousands of galaxies, so enormous that it challenges one of the fundamental principles of modern cosmology. This principle is called cosmic homogeneity. According to it, when the universe is viewed on extremely large scales, it should appear roughly the same in every direction. But this structure turned out to be so enormous that it seems to violate that rule. Its length exceeds 10 billion light-years. For comparison, the diameter of the observable universe is about 93 billion light-years. That means a single structure occupies a significant portion of cosmic space. When scientists first discovered it, they assumed it was an error in the data. But further observations confirmed that the object truly exists. And to this day, no one fully understands how it could have formed. Yet even this structure may not be the most mysterious object in the universe, because there is a signal that has been arriving from space for years. It appears suddenly. It lasts only a fraction of a second, and in that brief moment, it releases more energy than our sun produces in several days. Then it disappears, without a trace. The strangest part is that some of these signals repeat, but no one yet knows what is producing them. And it is these mysterious phenomena, the strangest objects in the universe, that scientists are trying to understand today. Because what they have discovered in recent years may one day change our understanding of the cosmos forever. In August of 1977, something extraordinary happened. At the Ohio State University Radio Observatory, a massive radio telescope known as the Big Ear was scanning the sky as part of a long-running search for signals from space. The project was designed to listen for unusual radio transmissions that might come from distant astronomical sources. Most of the time, the telescope detected nothing remarkable, only the quiet background noise of the universe. But on the night of August 15, 1977, a signal appeared that would become one of the greatest mysteries in the history of astronomy. The signal lasted for exactly 72 seconds. It was incredibly strong, far stronger than the usual cosmic radio emissions astronomers were used to seeing. Even more intriguing, it came from a very specific region of the sky near the constellation Sagittarius. When astronomer Jerry Eman reviewed the computer printout of the data days later, he immediately realized that something unusual had been recorded. Next to the strange sequence of numbers and letters representing the signal's strength, he circled the data and wrote a single word in red ink. Wow. That simple reaction gave the signal its famous name, the wow signal. What made the signal so mysterious was its precision. It appeared exactly at the hydrogen line frequency, around 1,420 megahertz, a radio frequency naturally emitted by hydrogen atoms. Scientists have long speculated that if an intelligent civilization wanted to send a signal across the galaxy, this would be a logical frequency to use, because hydrogen is the most abundant element in the universe. The signal was also extremely narrow band, meaning it was concentrated within a very specific frequency range. Natural cosmic sources usually produce signals across a broad spectrum, but this one was unusually focused. For a brief moment, the telescope had captured something that looked almost artificial. Then it vanished, and it has never been detected again. For decades, astronomers have searched the same region of the sky, hoping to catch the signal once more. But despite countless attempts, the mysterious transmission has never returned. Many explanations have been proposed. Some scientists suggested it could have been caused by a rare natural phenomenon, such as a passing comet interacting with hydrogen clouds. Others believed it might have been a reflection of a distant signal bouncing off space debris or satellites. But none of these explanations fully fit the data. To this day, the WOW signal remains unexplained. Yet the universe did not stop surprising scientists. In fact, many years later, astronomers discovered something even stranger. Beginning in the early 2000s, radio telescopes started detecting sudden bursts of radio energy coming from distant galaxies.
These events lasted only a few milliseconds, but in that incredibly short time, they released as much energy as the sun produces in several days. These mysterious events became known as fast radio bursts, or FRBS. At first, scientists thought the detections were simply instrumental errors. The signals were so intense and so brief that it seemed impossible for them to originate from real astrophysical events. But as more observatories around the world began detecting them, it became clear that the signals were real, and they were coming from extremely far away, sometimes from galaxies billions of light years from Earth. The discovery created a new mystery. What kind of cosmic object could produce such powerful flashes of energy? Several theories were proposed. Some researchers suggested that FRBS might be produced by magnetars, extremely dense neutron stars with magnetic fields trillions of times stronger than Earth's. Others proposed that they might occur during the collision of neutron stars, events so violent that they warp spacetime itself. But then something unexpected happened. Scientists discovered that some FRBS repeat. Instead of being one-time explosions, certain sources were sending out bursts over and over again.
This complicated the mystery even further.
If the bursts were caused by catastrophic events like stellar collisions, the source should disappear after the first explosion. Yet these repeating signals continued to appear again and again. In 2016, astronomers finally managed to trace one repeating FRB to a small galaxy about 3 billion light-years away. Even with this discovery, the exact mechanism behind these signals is still debated. But the universe had yet another surprise waiting, because somewhere in the depths of space lies a mysterious region that astronomers cannot even see directly. Yet its gravitational pull is affecting entire galaxies. This object is known as the Great Attractor. The Great Attractor is not a single object like a star or black hole. Instead, it appears to be an enormous concentration of mass located roughly 150 to 250 million light-years away from Earth. Astronomers discovered its presence by studying the motion of galaxies. When scientists measured how galaxies were moving through space, they noticed something unusual. Thousands of galaxies, including our own Milky Way, seemed to be slowly drifting toward the same invisible region of space. Something massive was pulling them. But there was a problem. The region where this gravitational force originates lies behind the dense clouds of dust and stars in the center of our galaxy. This area is known as the zone of avoidance because it blocks astronomers from seeing what lies beyond it. It is as if something enormous is hiding behind a cosmic curtain. Over time, observations using infrared and X-ray telescopes have revealed that the Great Attractor may actually be part of an even larger structure called the Laniakea supercluster, a vast cosmic region containing more than 100,000 galaxies. Our own Milky Way is just a tiny part of this immense structure. Yet even today,
Scientists are still trying to understand exactly what lies at the center of this mysterious gravitational pull. And as powerful telescopes continue scanning the sky, they keep discovering new phenomena that challenge everything we thought we knew about the universe. But perhaps the strangest discovery of all is something astronomers found when they looked at the largest possible scales of the cosmos. They discovered a structure so enormous that it should not exist at all. According to modern cosmology, structures larger than about 1 billion light-years should be extremely rare. Yet astronomers found something 10 times larger. A colossal formation made of thousands of quasars stretching across billions of light-years. And its existence may force scientists to rethink the very structure of the universe. For centuries, humans believed the universe was relatively simple on large scales. Stars formed galaxies, galaxies formed clusters, and clusters formed enormous cosmic webs stretching across space. But beyond a certain size, the universe was supposed to look smooth and uniform. This idea is known as the cosmological principle. According to this principle, when we observe the universe on extremely large scales, matter should be distributed fairly evenly. In other words, the cosmos should not contain structures so large that they dominate vast regions of space. For decades, this assumption formed one of the foundations of modern cosmology. Then, astronomers discovered something that seemed to break that rule. In 2013, a team of scientists studying distant quasars made a shocking discovery. While analyzing data from a large astronomical survey, they noticed that thousands of quasars appeared to be grouped together in a single enormous structure. Quasars are among the brightest objects in the universe. They are powered by supermassive black holes at the centers of distant galaxies. As matter spirals into these black holes, it heats up to incredible temperatures and releases enormous amounts of energy. A single quasar can outshine an entire galaxy. Because they are so bright, quasars can be observed across billions of light-years of space. This makes them useful tools for mapping the large-scale structure of the universe. But when researchers mapped the locations of certain quasars, they noticed something strange. Instead of being randomly distributed, many of them appeared to form a gigantic structure. At first, scientists thought it might simply be a statistical coincidence. But after careful analysis, the evidence suggested otherwise. The quasars were part of a single structure now known as the Huge Large Quasar Group, often abbreviated as the Huge LQG. Its size stunned the scientific community. The structure stretches across more than 4 billion light-years. To understand how massive that is, consider this. The entire Milky Way galaxy is about 100,000 light-years across. The Huge LQG is tens of thousands of times larger. If someone could somehow travel across this structure at the speed of light, the journey would take over 4 billion years. Even more surprising was the fact that the Huge LQG is not the only structure of its kind. Around the same time, astronomers discovered another massive formation called the Hercules Corona Borealis Great Wall. And this structure is even larger. It spans an estimated 10 billion light-years across space. To put that into perspective, the observable universe itself is about 93 billion light-years in diameter. A single structure occupying a significant fraction of that scale challenges existing theories about how the universe formed. According to current cosmological models, structures this large should not have had enough time to form since the Big Bang, which occurred roughly 13.8 billion years ago. Gravity simply shouldn't have been able to organize matter on such enormous scales. And yet, the observations suggest that these gigantic structures exist. Some researchers argue that these formations may not actually be single coherent structures. Instead, they could be chains of smaller clusters that only appear connected when viewed from Earth. Others believe that the models describing the early universe might need revision. But whatever the explanation, these discoveries forced astronomers to ask a troubling question. Is the universe really as uniform as we thought? Or are there hidden patterns on scales far larger than anyone expected? While scientists debated the nature of these colossal formations, another mystery appeared in the cosmic microwave background, the faint radiation left behind from the birth of the universe itself. This radiation is often described as the afterglow of the Big Bang. When astronomers mapped it in detail using satellites such as WMAP and later Planck, they expected it to be nearly uniform, with only tiny fluctuations in temperature. Most of the map looked exactly as predicted, but in one region of the sky, something unusual appeared. A massive area that was significantly colder than the surrounding regions.
This strange feature became known as the cold spot. At first glance, the difference in temperature seemed small, only a few microkelvin. But on cosmological scales, this anomaly was enormous. The cold spot spans nearly 2 billion light-years across. And despite years of study, scientists are still unsure why it exists. One explanation suggests that the cold spot may be caused by a gigantic cosmic void, a region of space with far fewer galaxies than usual. If light from the early universe passes through such a void, it can lose energy, appearing slightly colder by the time it reaches Earth. However, detailed observations have shown that the void in that region may not be large enough to fully explain the anomaly. Other hypotheses are even more exotic.
Some researchers have proposed that the cold spot might be evidence of a collision between our universe and another universe shortly after the Big Bang. If such an event occurred, it could have left an imprint in the cosmic microwave background. This idea belongs to a controversial theory known as the multiverse. According to this concept, our universe might be only one of countless universes existing within a larger cosmic framework. Most scientists remain skeptical of this explanation because it is extremely difficult to test experimentally. But the cold spot remains one of the most unusual features ever discovered in the cosmic background radiation. And it raises the possibility that the universe may still contain secrets far beyond our current understanding. Yet perhaps the most mysterious objects of all are not enormous structures or ancient radiation patterns. They are tiny points of light scattered throughout the universe. Objects so dense that a single teaspoon of their material would weigh billions of tons. Objects with gravity so powerful that they bend the fabric of space itself. Objects capable of swallowing entire stars. These are black holes. And in recent years, scientists have discovered versions of them so massive that they challenge everything we thought we knew about how black holes form. Some of them appeared in the universe far earlier than theory predicts. Others seem far too large to exist at all. And the deeper scientists investigate them, the more mysterious they become. Because black holes may hold the key to some of the most fundamental questions about the universe. And the strangest discoveries about them are only beginning to unfold. Few objects in the universe are as mysterious and terrifying as black holes. They are regions of space where gravity becomes so powerful that nothing, not even light, can escape. Once something crosses the boundary surrounding a black hole, known as the event horizon, it is lost forever.
For many years, black holes were considered purely theoretical objects. They were first predicted by Albert Einstein's theory of general relativity in 1915. According to the mathematics of relativity, if enough mass were compressed into a small enough space, gravity would become infinitely strong. At the time, even Einstein himself doubted that such objects could actually exist in nature. But decades later, astronomers began to find evidence that black holes were very real. Most black holes form when massive stars collapse at the end of their lives. After burning through their nuclear fuel, the star can no longer support its own weight, and gravity causes it to collapse inward. The result is an incredibly dense object with gravity so intense that it traps everything around it. These stellar black holes are already extreme enough. But in the centers of galaxies, scientists discovered something far more astonishing. At the heart of nearly every galaxy lies a supermassive black hole. These cosmic giants contain millions or even billions of times the mass of our Sun. The black hole at the center of our own galaxy, the Milky Way, is called Sagittarius A star. It contains about 4 million solar masses. But compared to some other black holes in the universe, Sagittarius A star is relatively small. Astronomers have discovered black holes containing tens of billions of solar masses. One example is the black hole inside the galaxy TON 618, one of the most massive known black holes ever observed. TON 618 contains an estimated 66 billion times the mass of the Sun. To understand how extreme that is, imagine compressing tens of billions of stars into a region smaller than our solar system. Yet even these giants are not the most puzzling part of the story. The real mystery began when astronomers looked deep into the early universe. Using powerful telescopes, scientists can observe galaxies whose light has traveled for billions of years before reaching Earth.
Looking farther into space means looking farther back in time. Some of the most distant quasars we observe formed when the universe was less than 1 billion years old. And at the centers of those galaxies, astronomers found something shocking. They already contained supermassive black holes with billions of solar masses. According to current models of cosmic evolution, black holes should grow gradually over time. They begin as smaller black holes formed from collapsing stars, and then slowly gain mass by absorbing gas, dust, and even other black holes. But the early universe simply did not exist long enough for such enormous objects to grow. It would take billions of years for a black hole to reach such extreme masses. And yet these ancient quasars already contained them. This created a serious problem for astronomers. How did these gigantic black holes grow so quickly? Several theories have been proposed. One idea suggests that the first stars in the universe were far larger than stars today. When these population 3 stars collapsed, they may have formed unusually massive black holes that served as the seeds for later growth. Another theory proposes the existence of direct collapse black holes, formed when enormous clouds of gas collapsed directly into black holes without first forming stars. Such events would create extremely massive black holes almost instantly. But even these explanations may not fully account for the most massive objects observed. Some researchers have suggested an even stranger possibility, that primordial black holes may have formed shortly after the Big Bang itself. These hypothetical black holes would have emerged from tiny fluctuations in the density of matter during the earliest moments of the universe. If they exist, primordial black holes could have served as the original seeds from which supermassive black holes later grew. They might even make up part of the mysterious substance known as dark matter, which accounts for most of the mass in the universe but remains invisible to telescopes. Despite decades of research, scientists still do not know which explanation is correct. But black holes continue to surprise researchers in unexpected ways. In 2015, a new kind of astronomical observation changed everything. For the first time in history, scientists directly detected gravitational waves, ripples in the fabric of space-time itself. These waves were produced by the collision of 2 black holes more than 1 billion light-years away. The discovery confirmed a prediction Einstein had made 100 years earlier. But it also revealed something strange. The colliding black holes were far heavier than astronomers expected. Each one contained more than 30 times the mass of the Sun, which was unusually large for stellar black holes. Since then, the LIGO and Virgo observatories have detected many similar events, including collisions involving black holes of even greater mass. Some scientists now believe that the universe may contain an entire population of black holes that formed in ways we still do not understand. And the mysteries do not stop there. In 2019, the world saw the first ever image of a black hole. The image was captured by the Event Horizon Telescope, a global network of radio telescopes working together to create a planet-sized observatory. The target was a supermassive black hole in the galaxy M87, located about 55 million light-years from Earth. The resulting image showed a dark shadow surrounded by a glowing ring of superheated gas. It was the first direct visual evidence of a black hole's event horizon. Yet even with this incredible achievement,
many questions remain unanswered. What truly happens inside a black hole? Does information disappear forever when it crosses the event horizon? Or could black holes be gateways to something even stranger, perhaps other regions of the universe?
Some physicists have proposed that black holes might be connected to wormholes, hypothetical tunnels through space-time. Others suggest they may hold clues about how gravity and quantum mechanics can be unified into a single theory of physics. Whatever the truth may be, black holes remain among the most mysterious objects in existence. But even they may not be the strangest objects in the cosmos, because somewhere in deep space, astronomers have discovered stars that should not exist at all. Stars that rotate so fast they nearly tear themselves apart. Stars made of matter so dense that atoms themselves are crushed into new forms of exotic particles. And perhaps the most extreme stars of all, objects that blur the line between stars and black holes. These are neutron stars, and the bizarre phenomena surrounding them are even more astonishing than the mysteries of black holes. Among the most bizarre objects in the cosmos are neutron stars. They are the collapsed cores of massive stars that exploded as supernovae. When a star several times larger than the Sun reaches the end of its life, gravity crushes its core inward with unimaginable force. The result is something so dense that it defies common understanding. A neutron star may contain more mass than our Sun, yet it is compressed into a sphere only about 20 kilometers across. To put that into perspective, imagine squeezing an object heavier than the Sun into a city-sized sphere. The density becomes almost impossible to imagine. A single teaspoon of neutron star material would weigh billions of tons on Earth. Under such extreme pressure, atoms cannot survive. Electrons are forced into protons, creating neutrons. What remains is essentially a gigantic atomic nucleus composed almost entirely of neutron matter. But the strange properties of neutron stars do not stop there. Some of them spin at incredible speeds. When the original star collapses, the conservation of angular momentum causes the newly formed neutron star to rotate faster and faster, much like an ice skater spinning more rapidly when pulling their arms inward. As a result, some neutron stars rotate hundreds of times per second. These rapidly spinning objects are called pulsars. Pulsars emit beams of radiation from their magnetic poles. As the star rotates, these beams sweep across space like cosmic lighthouse beams. When one of those beams crosses Earth, astronomers detect a pulse of radio waves. Some pulsars are so precise that their pulses arrive with greater regularity than the most accurate atomic clocks. When pulsars were first discovered in 1967, scientists were stunned by the perfect rhythm of the signals. The pulses arrived every 1.33 seconds with extraordinary precision. For a brief moment, researchers even considered a shocking possibility. Could the signals be coming from an intelligent civilization? The first pulsar was jokingly nicknamed LGM-1, which stood for Little Green Men. Of course, scientists quickly realized that the source was a natural astrophysical object. But the discovery demonstrated just how strange the universe can be. Yet even pulsars are not the most extreme neutron stars. Some neutron stars possess magnetic fields so powerful that they distort the very structure of matter. These objects are called magnetars. A magnetar's magnetic field can be 1,000 trillion times stronger than Earth's magnetic field. It is the strongest magnetic field known to exist anywhere in the universe. If a magnetar were placed halfway between the Earth and the Moon, its magnetic field would be strong enough to wipe the data from every credit card on our planet. If one came within a few thousand kilometers of Earth, its magnetic field could tear apart atoms themselves. Fortunately, The nearest known magnetars are located thousands of light-years away. Even at those distances, their power can still be detected. Magnetars occasionally release enormous bursts of energy, known as gamma-ray flares. In 2004, one such flare erupted from a magnetar about 50,000 light-years away. Despite that enormous distance, the burst was so powerful that it briefly affected Earth's atmosphere. It became one of the most energetic events ever recorded in our galaxy. But magnetars may also hold the key to another cosmic mystery. Many scientists now believe that at least some fast radio bursts, the mysterious millisecond signals discussed earlier, may be produced by magnetars during violent magnetic eruptions. If this is correct, then some of the most puzzling signals from deep space could originate from these bizarre stellar remnants. Yet neutron stars continue to challenge scientists in unexpected ways. In recent years, astronomers have discovered neutron stars that appear to lie in the so-called mass gap, a range of masses where theory predicted no objects should exist. Some are too massive to be typical neutron stars, yet too small to be black holes. This raises a fascinating possibility. There may exist exotic objects even stranger than neutron stars. One theoretical possibility is something called a quark star. Inside a neutron star, the pressure is so extreme that even neutrons might break apart into their fundamental components, quarks. If this occurs, the star could transform into an entirely new form of matter known as quark matter. Such objects would be even denser and more exotic than neutron stars. But scientists are not yet certain whether quark stars actually exist. Another hypothetical object is the strange star, composed of a special form of quark matter called strange matter. According to some theories, strange matter could be the most stable form of matter in the universe. If true, a strange star might remain stable under conditions that would destroy any ordinary neutron star. But so far, evidence for such objects remains uncertain. Yet perhaps the most astonishing neutron star discoveries involve their collisions. When two neutron stars spiral toward each other and merge, the resulting explosion releases enormous amounts of energy. These events are called kilonovae. In 2017, astronomers witnessed such a collision for the first time through both gravitational waves and light. The event revealed something remarkable. Many of the heavy elements in the universe, including gold, platinum, and uranium, are created during these collisions. In other words, the gold in jewelry, the platinum in electronics, and many other heavy elements on Earth were forged during the violent deaths of neutron stars billions of years ago. It means that some of the atoms in our own bodies were created in cosmic explosions far beyond our galaxy. Yet despite everything scientists have learned about neutron stars, the universe still hides objects that may be even more mysterious. Because astronomers have discovered stars that appear to vanish, stars that dim in ways no known theory can easily explain. And some of them behave so strangely that scientists once wondered whether they might be surrounded by gigantic artificial structures built by advanced civilizations. One such object became famous around the world. It is known as Tabby's star, and its strange behavior has puzzled astronomers for years. In the vast darkness of space, most stars behave in predictable ways. They shine steadily for millions or even billions of years, slowly burning the nuclear fuel in their cores. Occasionally, they flicker slightly when planets pass in front of them, or when stellar activity causes temporary changes in brightness. But astronomers discovered one star that seemed to defy all of these patterns. It is located about 1,480 light-years from Earth in the constellation Cygnus. Officially, the star is known as KIC 8462852, but around the world, it became famous under a different name,
Tabby's star. The name comes from astronomer Tabitha Boyajian, who first led the scientific investigation into the star's strange behavior. The mystery began during the Kepler Space Telescope mission. Kepler's primary task was to search for planets around other stars. It did this by monitoring the brightness of over 150,000 stars, looking for tiny dips in light caused by planets passing in front of them. Normally, when a planet crosses in front of a star, the brightness drops by a tiny fraction, usually less than 1%. The pattern is regular and predictable, but when astronomers examined the data from KIC 8462852, they found something extraordinary. The star's brightness sometimes dropped by as much as 20%. This was completely unprecedented. No known planet could block that much light from a star. Even stranger, the dimming events were irregular. They didn't occur at consistent intervals, and they lasted for different lengths of time. Sometimes the star dimmed for several days. Other times, the brightness slowly faded over weeks. There was no clear pattern. At first, astronomers suspected that the telescope data might be flawed. But after carefully checking the observations, they confirmed that the strange dimming was real. Something was blocking the star's light. The question was, what? Scientists proposed several natural explanations. One possibility was that a massive swarm of comets was passing in front of the star. Another idea suggested that a giant cloud of dust surrounded the star, occasionally drifting into our line of sight. Others proposed that the star may have recently swallowed a planet, creating debris that temporarily blocked its light. But none of these explanations completely fit the observations. The dimming events were too large, too irregular, and sometimes too complex. Then a more unusual hypothesis appeared. In a scientific paper discussing the star, researchers mentioned the possibility, very cautiously, of a Dyson swarm. A Dyson swarm is a theoretical collection of megastructures built by an advanced civilization to capture the energy of a star. Unlike a solid sphere, a Dyson swarm would consist of many satellites orbiting the star, forming a loose shell of energy-collecting structures. If such objects existed, they could block starlight in irregular ways. This idea captured the imagination of people around the world. For a brief moment, some wondered whether astronomers had discovered evidence of an advanced alien civilization. However, scientists remained extremely cautious. Extraordinary claims require extraordinary evidence. Researchers began studying the star in greater detail using telescopes around the world. Over time, new observations provided important clues. Astronomers discovered that when the star dimmed, the light became slightly redder. This suggested that the object blocking the light was made of dust particles, not solid structures. Dust tends to scatter blue light more strongly than red light, which changes the color of the star during dimming events. Eventually, many researchers concluded that the most likely explanation involved large clouds of cosmic dust, possibly created by the breakup of comets, asteroids, or even fragments of planets. Yet the full story may still not be completely understood. Tabby's star remains one of the most unusual stars ever observed, but even stranger discoveries were still waiting. Because while astronomers were studying mysterious stars, another unexpected signal arrived from the depths of space. Unlike the brief flashes of fast radio bursts, this signal behaved very differently. It followed a regular pattern. It repeated every 16 days. The signal came from a galaxy 500 million light-years away, and it raised an entirely new set of questions. Because in the universe, repeating signals with precise timing are extremely rare. What kind of cosmic object could produce such a pattern?
Scientists suspect that the source may involve a neutron star interacting with another massive object, possibly in a binary system.
As the objects orbit each other, the signal becomes visible only during certain parts of the orbit. But even this explanation may not fully account for all the observations. And these repeating cosmic signals are not the only mysterious phenomena in the universe. In fact, some astronomers believe that we may be missing an enormous part of the cosmic picture. Because most of the universe is made of something that scientists cannot even see, something that does not emit light, something that cannot be directly detected by telescopes, yet its gravitational influence shapes the motion of galaxies and the structure of the entire cosmos. This mysterious substance is known as dark matter, and it may represent one of the greatest unsolved mysteries in modern science. For centuries, humans believed that everything in the universe was made of the same kind of matter we see around us every day: stars, planets, gas, dust, and galaxies. But modern astronomy has revealed something astonishing. Almost everything we see in the universe is only a tiny fraction of what actually exists. In fact, all the stars, planets, nebulae, and galaxies combined make up less than 5% of the total universe. The rest is made of something far more mysterious. About 27% of the universe is composed of an invisible substance known as dark matter, and another 68% is made of something even stranger: dark energy. Together, these invisible components make up about 95% of the entire universe, and yet scientists still do not know exactly what they are. The story of dark matter began in the early 20th century. Astronomers studying the motion of galaxies noticed something unusual. When galaxies rotate, the stars near the edges should move more slowly than those near the center. This is how gravity works. Objects farther from the center feel less gravitational pull, but observations showed something different. Stars at the outer edges of galaxies were moving much faster than expected. According to the visible matter in those galaxies, the stars should have been thrown out into space, but they remained in stable orbits. Something invisible was holding them together. This mysterious gravitational influence became known as dark matter. Although it cannot be seen directly, astronomers have detected its effects throughout the universe. Dark matter shapes the formation of galaxies, bends light through gravitational lensing, and influences the motion of galaxy clusters. Without dark matter, the universe would look completely different. Galaxies might never have formed at all. But despite decades of research, scientists still do not know what dark matter is made of. Several possibilities have been proposed. Some theories suggest that dark matter may consist of unknown particles called WIMPs, or weakly interacting massive particles. Others propose extremely light particles known as axions. There are even theories suggesting that dark matter might consist of tiny primordial black holes formed shortly after the Big Bang. So far, none of these candidates has been directly detected. Experiments deep underground, particle accelerators, and space observatories have all searched for dark matter particles, but the universe has remained silent. Yet dark matter is only part of the mystery. In 1998, astronomers studying distant supernovae made another shocking discovery. They expected the expansion of the universe to be slowing down due to gravity. Instead, they found the opposite. The universe was expanding faster and faster. Something was pushing galaxies apart. This mysterious force became known as dark energy. Unlike dark matter, which pulls objects together through gravity, dark energy appears to do the opposite.
It acts like a kind of cosmic anti-gravity, driving the accelerating expansion of the universe. Today, scientists believe dark energy dominates the cosmos. It makes up nearly 70% of everything that exists. But its true nature remains one of the greatest puzzles in physics. Some theories suggest that dark energy may be a property of empty space itself.
Others propose entirely new forms of energy or modifications to the laws of gravity. For now, the answer remains unknown. And when scientists add together all these mysteries, dark matter, dark energy, black holes, neutron stars, unexplained signals, and gigantic cosmic structures, they arrive at a remarkable conclusion. The universe is far stranger than anyone once imagined. Every time astronomers build more powerful telescopes and look deeper into space, they discover something new. Sometimes these discoveries confirm existing theories, but just as often, they raise even more questions. It is possible that the universe contains phenomena we have not yet even begun to imagine. Objects made of exotic forms of matter, structures larger than any we have seen so far, signals from distant corners of space that carry information about unknown cosmic events, or perhaps entirely new laws of physics waiting to be discovered. Humanity has explored only a tiny fraction of the cosmos, and yet, even that small glimpse has revealed a universe filled with wonders and mysteries. Some of them may take centuries to understand. Others may remain unsolved forever. But one thing is certain. The deeper we look into the universe, the more we realize how little we truly know. And somewhere out there, beyond the reach of our telescopes, the strangest objects in the universe may still be waiting to be discovered.